In this video, we are going to look at the introduction to trigonometry. Now, trigonometry is defined as the branch of mathematics that deals with the measurements of triangles. So here we may have a non-right angled triangle and a right angled triangle, but for this particular video, we'll focus on a right angled triangle. So now, under the right angled triangle is where we use the three trig ratios, and we use the mnemonic known as SOH TOA. Now, what you need to have in mind is these trig ratios, the three trig ratios that I've written here, can only be applied if the given triangle is a right angled triangle. Now, so since we have introduced the word of a right angled triangle, let's draw this right angled triangle. So there are some basics that we need to have for us to deal with the three trig ratios. So the first thing that we need to do is the 90 degrees. This angle should not be used in calculations. This angle helps us to identify the distance known as the hypotenuse. So always the distance opposite to this angle is known as the hypotenuse. Then if our angle under consideration theta is this angle, the distance next to this theta, this is the adjacent. Then this distance opposite to this theta, this is our opposite side or distance. Now, let's look at these three trig ratios. So the first one, we'll look at the So S represents the sine. So sine theta is equal to opposite side divided by hypotenuse. Then the second one, we have this CAH. So CAH, C for cos theta is equal to adjacent divided by hypotenuse. Then for the last trig ratio, we have TOA for T for tan. So tan theta is equal to opposite divided by adjacent. Now, the other thing that you need to have in mind is for you to understand this topic fully, you need to have also the Pythagorean theorem in mind, because you may be required to find the all three trig ratios, and you may be given two distances, and for you to find the third distance, you may be use the Pythagorean theorem. So let's say we have this right angled triangle. Now for this right angled triangle, if we are using Pythagorean theorem, this is our hypotenuse, the same. Then this is our adjacent, and also here we have the adjacent. So under Pythagorean, we don't have distances like opposite. Now for the formula that we can use to find the missing side using Pythagorean theorem is the longest side. This side is C, then this can be our A and our B. So the formula is C squared is equal to A squared plus B squared. So let's say maybe we want A. If we want A, it is A squared is equal to C squared minus B squared. If we want B, it's B squared is equal to C squared minus A squared. Okay, now let's look at the first example. So let's say we have this right angled triangle. Under this right angled triangle, we have this distance 4 centimeters, and here 3 centimeters, and let's say our theta is here. Now the question is, we want to find the value of sine theta cos theta and tan theta. Now, since we are required to find the all three trig ratios, we need to have the all three distances. So now let's look at the data that we have. So we can see that we have the two distances, and we want to find now the third distance. So for us to find the third distance, we are going to use the Pythagorean theorem. So this is our C, A, our B. So the formula is C squared is equal to A squared plus B squared. So our A squared is 3 centimeters, so we can just say 3 squared plus 4 squared. So if we square 3 times 3 is 9 plus 16. So we can add, this is giving us 25, then we can find the square root for each part. So this will cancel, giving us C is equal to the square root of 25 is 5. So this number here is 5. Now, before we proceed with finding the final answers, first we need to identify which distance is our opposite, adjacent, and hypotenuse. So from this angle here, we can see that this distance here, this is our opposite. Then the distance next to our theta, this is our adjacent. Then for this one, this is always our hypotenuse. So now we can proceed. We can now begin by finding the sine. So sine is so it is sine theta is equal to opposite divided by hypotenuse. So sine our theta is equal to the opposite is 3 centimeters over 5 centimeters. So we can now cancel the centimeters. So if we cancel this, our final answer is 3 over 5. So this is our ratio. Now for the second one, cos. So for cos is cos theta equals adjacent divided by hypotenuse. So the adjacent is 4 centimeters divided by the hypotenuse is 5 centimeters. So we can cancel this. Our final answer, cos theta, is equal to 4 over 5. Then for the tan, TOA, so tan is given by tan theta is equal to opposite divided by adjacent. So our opposite is 3 centimeters over adjacent is 4 centimeters. So we can cancel the centimeters, giving us 3 over 4. So these are just the ratios, but if you are taught to find the actual angle, you can use the calculator to find the actual angle. Okay, so now let's move on to the second question. Now for this second question, we are going to find the missing sides. So let's draw our triangle here. Now for we have this 49 degrees, then 9 centimeters. Then our work is we need to find the distance B and C. So for those that have ideas, you may pause the video and give it a try. So the first step that we are going to do is we need to identify the opposite, adjacent, and hypotenuse. So this distance, this is our opposite. Then for this one is hypotenuse. Then here we have our adjacent. So now let us write the 3 trig ratios. Now, so we'll begin by first let's find the B. So let's look at where B is. So B is only adjacent. Now when you are not given all the three distances, from the three trig ratios you need to choose one or maybe two. We can say one trig ratio that is correlating with the data that you have. So from there we can see that the hypotenuse is given and our task is to find the adjacent. So from these three trig ratios, we want a trig ratio where we have adjacent and the hypotenuse. So we have the CAH. So CAH, here we have the adjacent is what we are looking for. Then the hypotenuse is given. So this is given as cos theta is equal to adjacent divided by our hypotenuse. So let's look at the cos. So the angle under consideration is 49 degrees is equal to adjacent is just b. This is what we are looking for. Then the hypotenuse is 9 centimeters. So over 1 we can now cross multiply so that we can solve for b. So 1 multiplied by b is just b. Then cos 49 times 9 centimeters, I'm getting about 5.9 centimeters. So this is the distance for this part. So we have calculated this one to be 5.9. Now from there let's solve for O, which is opposite our C. So from there we can use the TOA part can also be applied. So let's first begin. Let's use the TOA. So this is tan theta is equal to opposite over adjacent. So tan, the angle, what angle is that one? 49. The opposite is the C. The adjacent is 5.9. So over 1 we cross multiply. 1 times C is C. So tan 49 times the 5.9. So I'm getting about 6.787. So 6.8 centimeters. Now let's also find the same distance C using the sine part, since we can see that under the SOH we have the opposite, the one we are solving, and the given distance, which is hypotenuse. So this is sine theta is equal to opposite over hypotenuse. So here we have sine 49 is equal to our opposite is C. Then the hypotenuse is 9 centimeters. So the same over 1 cross multiply. So 1 times C is C. Sine 49 multiplied by 9. I'm also getting 6.792, which is 6.8. So we can see that regardless of the trig ratio that you choose, the answer will always be the same, or maybe the difference may be small because of rounding off. Now let's also try another example. Now for this time we have this right angle triangle. Under this right angle triangle we have distances like 8, 14. So PQ R. So here the question is we want to find angle R. So we want to find which angle is on this R. So let's put theta. Okay, now after denoting this, we need to identify which distance is opposite. So our opposite distance is 8. Our adjacent is this one. Then our hypotenuse is 14. Then from there we need to choose which one from the three trig ratios can be applied to find a given angle. So our focus is we need to look at what do we have what do we have? Then whatever that we have will help us to choose the trig ratio that can be applied. So from there we can see that we have opposite and the hypotenuse. So from the three trig ratios, which one consists of the opposite and hypotenuse? So we can see that this is our appropriate trig ratio. So this is sine theta is equal to opposite divided by hypotenuse. So sine, our theta we are solving is r, opposite is 8 over 14. So let's now divide. So if I divide 8 divided by 14, I'm getting this number 0.571428571. Then what we are going to do is we need to shift the sign. So if we shift the sign, we get r is equal to sine inverse of 0.571428571. Then we can now find the final answer. So you press shift, sign answer, then my final answer is about 34.8, which is same as 35 degrees. So this is how you can calculate the angle given the two distances. So it is very important you look at the data that you have, so that it helps you to identify the trig ratio that can be applied. Now let's also try another one. So this time this is 25 degrees, then here we have 40, then here we have a 10 centimeters here, B, C, D. Then our task for this, first we need to look at it, we need to calculate the distance BD. Then the second one, we'll solve BC. Then the third one, DC. So you can pause the video and also you give it a try. So let's now see. So BD. So we can see that we have two triangles here. We have two triangles. There is this triangle ABC, and there is also this triangle ABD. So what I'm going to do is I'm going to separate the two triangles. So we have this bigger triangle here. Now for this triangle, the bigger one is, we have D here, B and A, then 10 centimeters. Then for the smaller triangle, our smaller triangle, this is our smaller triangle, it is A, B, C. Now this smaller triangle has an angle 40 degrees. Then for the larger one, this one, we need to add, since we are looking at the whole angle here, so we need to add 40 degrees plus 25 degrees is giving us 65 degrees. Okay, now after we are done this, we need to look at the first question, our BD. So our first question is, we are solving for BD. So for us to find the BD, first let's indicate. So BD, we can see that BT is opposite, then our AB is adjacent, then this one is hypotenuse. So from there, we can now look at the three trig ratios. So from there, let's look at where is BD. So BD is on opposite side. So we need to select the trig ratio that has the opposite and adjacent. So where there is opposite and adjacent is TOA. So this is tan theta is equal to opposite over adjacent. So tan, what angle is that one? 65. So the opposite is just BD. This is what we are solving for. The adjacent is 10 centimeters. So over, cross multiply, 1 times BD. Then so tan is 65 times 10 centimeters. I'm getting about 21.4 centimeters. So this is the distance BD. Now let's move on to BC. So for BC we are going to use the smaller triangle, since here we have a 10 centimeters. So for a smaller triangle, also this is our opposite, hypotenuse and adjacent. So even this one, we can see that we are going to use the tan party, since the distance that we are solving is on O and we have given the adjacent. So let's say tan theta is equal to opposite over adjacent. So tan, this time the angle is 40, opposite BC, adjacent 10 centimeters, so over 1, and we are expecting to get a smaller number. This number should be less than 21.4, since BC is less than BD. So tan 40 times 10, I'm getting 8.4. So 8.4 centimeters. Now let's look at DC. For DC, we are just looking at the distance from here up to here. So what are we going to do? Under this question, we are not going to use the trigonometry for this one. We are just going to use to subtract. So what we are going to do is DC is equal to BD. We have the distance BD minus the distance BC. So from B to D is 21.4 minus B to C 8.4. So 21.4, this should give us 13. So our final answer here, this is 13 centimeters. So this is just the introduction for trigonometry. If you are new to this channel, please consider subscribing, comment, like the video, and share. Thanks for watching.